Okay, let's unpack this. Imagine you're snorkeling, right? Clear water, maybe just standing by an aquarium. Have you ever had that feeling? That a fish isn't just, swimming past, but it's actually stopping, looking right at you. Maybe even seems a little bit curious.
Oh, yeah, absolutely. It's a really common experience.
It is, and it just sparks so many questions, doesn't it? Like, what is going on inside their heads? These creatures are fascinating.
They really are. And the truth behind that, look, well, according to the sack of sources we've been digging into for this deep dive, it's maybe way more complex, more surprising than we usually give fish credit for.
How so?
Well, that direct gaze, it might very well be curiosity, just like you said. And in some cases, especially with fish they see regularly, like pets, there's even evidence that hints at a form of recognition.
Recognition, curiosity.
Yeah.
Now, that immediately throws out a lot of what I think most people assume about fish.
Right.
So, okay. Today, we are taking a really deep dive. We've got a set of fascinating sources, all focused entirely on fish.
Yep. And the material tackles some common questions head on, but also uncovers some genuinely surprising facts about these underwater inhabitants.
So our mission today is basically to get beyond the surface level, literally and figuratively.
Yeah. We want to pull out the most interesting bits of knowledge from these sources, try to get a more fundamental grasp on fish life, physiology, senses, behavior, maybe even hints of, dare I say, sentience.
Ooh, intriguing.
And hopefully, through all this exploring, help you look at fish in a whole new light the next time you see one.
All right, let's dive right in then, starting with that classic interaction, humans and fish. Whether you're just watching them or maybe you're out snorkeling, we kind of carry this assumption, don't we, that fish must be terrified of us, that any sudden move sends them scattering in pure panic.
Yeah, that's the standard picture. But the source material, it offers a pretty startling counterpoint to that.
Okay, tell me.
It really flips that script.
Okay.
The direct answer in the source to "Are fish afraid of people?" is surprisingly just no.
Just no. Flat out.
Pretty much. And the explanation they give gets right to the heart of fish biology. It's not about us being uniquely scary as humans. The source explains that a fish's nervous system, well, it just isn't wired with the complexity needed to recognize individual humans or even to process fear in the way we experience it.
You mean that whole complex emotion tied to, like, self-awareness and specific memories of threats?
Exactly. That nuanced stuff. Their system isn't set up for that kind of cognitive processing regarding fear of a specific person.
Huh. That's a huge distinction. So it's not that they're brave, it's more that the concept of being afraid of me, the human, isn't really in their biological programming.
That's a great way to put it. Their biology just doesn't support it in the human sense.
So if that kind of complex human-like fear isn't possible, what does their nervous system allow for? What are they reacting to?
Right. The source clarifies their nervous system is super efficient, but it's optimized for the essentials. Survival functions. It fully supports hunting for food, detecting predators, reacting instinctually, to general threat cues like sudden movement or vibration, and of course reproduction.
Okay, so basic survival kit.
Pretty much.
Right.
Their wiring is all about immediate instinctual responses, stuff that's crucial for staying alive and making more fish. It's not about recognizing specific individuals and forming complex emotional judgments about them.
So if I'm swimming and a fish darts away, it's not thinking, oh no, it's Dave. He almost netted me last Tuesday.
No, definitely not Dave. It's more like an automatic response to the motion itself, or maybe the pressure wave you create in the water.
Okay.
They instinctually register that as something potentially threatening, like a predator lunging, maybe.
Yep.
Yeah, the source makes that really clear. If you move suddenly, aggressively, your actions just look like predator actions to them. And the fish's programmed response is defense, evasion, hiding, maybe sometimes even a protective nip. But it's triggered by the action, the stimulus in the water, not by recognizing your human ID and feeling fear towards you.
Right.
The contrast the source draws is key. Our complex layered nervous system versus their simpler action response focused system. Understanding that is fundamental to understanding how they act around us.
That really reframes every interaction, doesn't it? If they aren't acting out of fear of us specifically, then that staring, that direct gaze we started with, starts to make more sense.
Exactly.
So why do they stare then, if not fear?
The source points straight to curiosity.
Curiosity, really.
Yeah. You, the snorkeler, the person by the tank, you're just different. You're not the usual coral, not a bit of seaweed, not a familiar fish or predator they recognize instantly. You're like an anomaly.
So they're basically thinking, what is that?
Precisely. And in the wild, like when you're snorkeling, The source suggests this staring, maybe even following you a little bit, isn't a sign you're terrifying them. It's actually a good sign. It means they probably don't see you as an immediate high-level threat right then and there.
Huh. So instead of feeling bad for scaring everything.
Yeah. The source encourages you to see it as an opportunity. Appreciate the encounter, maybe snap a picture. You're getting to witness their natural behavior up close because they aren't panicked.
That's a much nicer way to think about it. Curious neighbors, not cowering creatures. And this curiosity thing, it seems really relevant when we think about pet fish.
Definitely.
Anyone who's had a fish tank, you feel like your fish recognize you, right? Does the source back that up?
It absolutely does. And this is where the source gets really interesting, actually. It goes a step further. It explicitly states that pet fish in an aquarium can and do start to recognize their owners. And they get familiar with their surroundings over time.
Okay, so it's not just me projecting.
Apparently not. The source interprets recognition not just as like basic learned behavior, but as something that implies, well, it implies a form of memory.
Yeah.
And maybe even importantly, basic emotion.
Oh.
Emotion. Now, hold on. It's careful to say this isn't human emotion, not sadness or joy like we feel it.
Yeah.
But it suggests a capacity for internal states beyond just pure instinct.
So that feeling that my goldfish, greets me when I come to the tank, there might actually be something to that. Real recognition and maybe a simple emotional response.
That's what the source suggests. Yeah, it gives a really concrete example. Pet fish learning to associate your voice or just seeing you approach the tank with feeding time.
Ah, the classic Pavlovian fish.
Kind of. If you always talk to your fish before you drop the food in, they learn that sound or seeing you means food's coming. And the source points to their behavior, swimming excitedly to the top, getting active right when they hear you or see you as evidence of learned recognition, memory tied to a positive thing. Food. Yeah, this demonstration of learning and association is a key takeaway from the source. It really challenges that old idea of fish being just simple, unthinking machines.
Okay, that adds a whole new layer of depth to keeping fish. They're not just swimming decorations. They're actually learning, responding, engaging.
Seems so.
So, okay, they might be curious. Pet fish can recognize us. What about more direct interaction? If we're actually in the water with them, like snorkeling, do fish generally like having snorkelers around?
Generally speaking, the source says no, they don't particularly like snorkelers.
Okay, why not?
It circles back to movement, mostly. Your actions, kicking your fins, waving your arms, even if you're trying to be gentle, these are often perceived as the movements of a potential predator.
Right. So my graceful attempts at swimming might look more like a shark on the prowl to them.
More or less. Could be. And the consequence, the source notes, is that your presence, and particularly your movements, can make them hide. If you're splashing around moving erratically, you're not just triggering their getaway instinct, you're also making it hard for yourself to see them naturally because they'll be darting for cover.
Makes sense.
So the source's advice here is pretty practical, both for the fish's comfort and for your viewing pleasure. Swim calmly. Move slowly. Keep a respectful distance. Be a quiet observer, not a disruptive force.
Good advice. And in that scenario, calm observation, do fish ever actually touch you? Assuming you're not doing anything silly like trying to feed them.
The source says generally, no. Fish won't usually touch a snorkeler who's just swimming calmly and watching. They navigate their world with incredible precision using senses we'll get into later. They can easily swim around you. The main exception the source mentions is, if you are trying to feed them. That can cause them to swarm or get close enough for accidental contact as they compete for the handout.
And the source includes a pretty strong warning against feeding them, doesn't it? Not just because they might touch you.
Absolutely. Very clear warning. The source specifically highlights that feeding wild fish can create unnatural competition among them, which can escalate fast. And that competition, unfortunately, is when they can get aggressive and potentially bite.
Bite. Okay, that leads us right there. Can a fish actually bite a snorkeler? It sounds like yes sometimes.
And the source confirms it.
Yeah.
Yes, fish can bite snorkelers. It explains this usually happens not out of aggression for aggression's sake, but when a fish feels threatened or cornered, it chooses defense attack instead of just fleeing or hiding. It's that fight response when flight doesn't seem like an option.
Is this like a super rare shark attack level event, or is it something that happens?
According to the source material, looking across different activities, snorkeling, fishing, just swimming, getting a fish bite is described as not uncommon.
Not uncommon, really.
Yeah. So while the vast majority of snorkeling trips are totally bite-free and wonderful, the source presents it as something you should be aware could happen when you enter their world.
Okay. And if it does happen, how bad are we talking? A little nip or something serious?
The source offers some reassurance there. It states that most fish bites are not serious. Phew.
Okay, good.
But it adds the important caveat. The severity really depends on the species. Some fish just have much sharper or bigger teeth than others. Bites from those species can definitely be more painful, cause deeper wounds, and potentially be more serious, needing proper attention.
So knowing the local ferret life might be helpful. And what's the advice from the source if you do get a serious bite?
The guidance is straightforward, very cautious. Get medical help right away. It specifically says go to the nearest emergency room, let a doctor check it out and treat it.
Sensible.
The source even suggests maybe proactively bring a basic first aid kit when you go snorkeling, just in case. But again, it balances this by saying most people have totally positive snorkeling experiences without any issues.
That's good to hear. So the main takeaway here is really be aware, stay calm, respect their space to avoid triggering that defensive reaction, and just know the plan if something, particularly something serious, were to happen.
Precisely. Awareness and calm respect. Best approach.
Okay, now shifting slightly to a different kind of interaction mentioned. Actually catching fish. Can you catch fish while you're snorkeling?
The source says it completely depends on where you are. Sometimes, yes, sometimes no.
How so?
Well, some places are protected marine areas. Fishing, taking any marine life, is strictly forbidden there to conserve the ecosystem. Makes sense. But other areas might allow it, probably under specific rules and regulations.
And the source mentions something specific, snorkel fishing.
Yeah, it describes snorkel fishing as a fairly new tradition. It's basically hunting fish while you're geared up for snorkeling. The source mentions it might require specific gear. It lists snorkel fins, for instance, and that there's definitely a learning curve. The advice for anyone interested is check with local experts, understand the rules, the regulations for that specific area, and maybe get some guidance on how to do it properly and safely.
That really highlights the huge range of how we interact with fish, doesn't it? From just quiet, curious watching all the way to actively hunting them. And it all varies so much by place and purpose.
It does. And it's a reminder that their world intersects with ours, and our rules and activities impact them directly.
Okay, let's shift gears a bit. Away from how we interact with them and more towards understanding them as biological creatures. This might sound super basic, but sometimes there's confusion, right? Are fish definitively, like 100% animals?
The source is absolutely crystal clear on this, yes. Fish are, in every biological sense, animals. Full stop.
Yeah.
It emphasizes that the animal kingdom is massive, incredibly diverse, way beyond just land mammals we might first think of. Fish belong firmly in that kingdom, alongside birds, reptiles, insects, everything else.
So it's not just about having lungs or fur or legs.
Not at all. The source gives a simple rule of thumb. Generally, apart from maybe some single-celled protists, if it moves under its own power, it's usually considered an animal.
Yeah.
But for more technical definition, the source points to a key fact about fish. They're vertebrates. They have a backbone, the spinal column.
Right.
And critically, all vertebrates are classified as animals. That's a fundamental biological category. So yes, fish are animals.
Okay, fish are animals. Check. Let's look at one of their most iconic features. Scales.
Mm-hmm.
Do all ocean fish have scales?
The source says most ocean fish do, yeah. But importantly, not all of them, and even among the ones with scales, there's amazing variety. Different types, sizes, structures. It's not one size fits all.
What drives that variety? Is there an evolutionary reason for different scales?
Absolutely. The source highlights a key trade-off. Protection versus speed. Fish needing serious protection, maybe from predators or scraping against rocks, often have thicker, larger scales. But those thicker scales can create more drag, slow them down. On the flip side, fish built for speed, think oceanic sprinters like tuna, or even fast freshwater fish like trout, tend to have much thinner, smaller, more streamlined scales. Less friction, faster swimming.
Like aerodynamic design, but for water.
Exactly. And slower fish, like carp, might have larger, more obvious scales. It's adaptation.
That's fascinating. Just scales telling a story about lifestyle. Does the source give examples of fish that don't have scales or have something totally different?
Yep. Several examples. It mentions the cyclostomes, that includes lampreys and hagfishes. They're ancient fish groups that lack scales. Interestingly, though, the source notes their very distant ancestors did have scales, so they lost them somewhere along the evolutionary road.
Huh.
Other examples without scales. The source lists sunfish, and some types of naked catfish.
Okay. What about sharks and rays? Their skin feels like sandpaper, totally different from a salmon. Do they have scales?
Good question. The source clarifies this. Sharks and stingrays do have scales, but they're structurally very different from the overlapping scales of bony fish. They have what are called placoid scales. Think of them less like plates and more like tiny, hard, tooth-like structures embedded in the skin. That's what gives them that rough texture.
Like tiny teeth all over their body. Wild.
Yeah. And the source also mentions other scale types in bony fish, cosmoid, ganoid, elasmoid, dectinoid, cycloid, just hammering home the sheer variety out there.
So even something we think is simple, like fish scales, reveals this incredible evolutionary journey and adaptation for protection, speed, different lineages.
It's a perfect example of the diversity hidden within the word fish.
Okay, moving deeper into their biology. Let's talk senses. How do fish actually perceive their world? It must be so different from us living in air.
Oh, fundamentally alien to our experience.
Yeah.
And the source provides some truly mind-bending details. Let's start with hearing. Can fish hear us? Yes, the source confirms fish can hear humans. Now, they don't have external ears like us, those flaps on our heads. Their ears are internal. In bony fishes, they have these special, dense, bony structures called ear stones. Technically, otoliths inside their inner ear.
Otolith. Yeah.
These otoliths are denser than the fish's body in the water. So when sound vibrations travel through the water and the fish, the otoliths lag behind slightly or move differently. This movement is detected by sensory hairs, and boom, they perceive sound.
So the vibrations from my voice, or splashing, travel through the water and actually make these little stones wiggle inside their head.
Pretty much. Sound travels really well through water, and fascinatingly, the source notes our ears and fish ears share a function. Balance. Both use inner ear structures to sense orientation and movement.
Huh. Hearing and balance linked. That's unexpected. And going back to the pet fish recognizing voices that must be tied directly to this hearing ability.
It is. The source uses that exact example. Pet fish learn to associate the sound of a specific voice with food. Their ability to pick out your voice from background noise is down to their hearing, and their learned response, swimming up, shows they can store memories and make connections based on sound. It suggests learning beyond just simple reflex.
Okay, so they hear external sounds, but what about the water itself? Are they constantly hearing the water they're in?
That's a subtle but really interesting point the source makes. While they can hear sounds in the water, being totally immersed means they probably don't hear the water itself as a constant sound, not like we might hear background air hiss. The source uses a great analogy. Think about how your brain filters out the constant sensation of the air on your skin, or even seeing your own nose all the time.
Right, you just tune it out.
Exactly. Your brain prioritizes new or important stuff. A fish's brain likely does the same with the constant presence of water. It's the background noise.
Okay, that makes total sense. Filter out the constant, focus on the changes.
Right. But what they do use constantly to perceive their immediate watery world, maybe even more than hearing as we think of it, is their lateral line system.
Ah, the lateral lane. I've seen that stripe on fish.
Yeah. It's this amazing sensory organ running along their sides. It's made of thousands of tiny hair cells called neuromasts, usually in canals just under the skin. These little hairs detect tiny water movements, vibrations, pressure changes. Super sensitive.
So the lateral line is like a full-body vibration detector, picking up stuff they might not even hear with their inner ears.
That's a good way to think about it. The source emphasizes this system is absolutely crucial for their survival. It's their primary tool for finding food, feeling the movements of prey or other fish, navigating currents, and critically detecting enemies approaching, maybe from the pressure wave they push. It gives them this dynamic, real-time map of subtle shifts in their world that we just can't perceive at all.
Wow. So they hear sounds for specific cues, but feel the water constantly with the lateral line. Okay, what about seeing? Can fish see in the dark, deep down, or in murky rivers?
The source says technically, yes, they can see in low light, or what we call dark. But their vision is adapted differently depending on where they live, and it's often supplemented, or even replaced, by other senses. Again, that lateral line system, with its neuromasts, helps them sense nearby objects even when they can't see well.
But that's feeling, not seeing with eyes.
Correct.
Right.
But fish have evolved some absolutely astonishing ways to perceive their environment beyond just standard vision. The source mentions incredible examples. Some fish, like the elephant fish in murky African waters, use electric fields to find prey. They generate a weak field around themselves and use special electroreceptor organs to detect distortions caused by objects or other creatures.
Whoa, electric sense.
Yeah, and some zoologists think they might even use these signals to build a kind of 3D image of their surroundings, essentially seeing with electricity.
Seeing with electricity, that is genuinely mind-bending stuff. What about the really deep sea, pitch black down there? Do their eyes even work?
Deep-sea fish have some of the most extreme adaptations. The source notes some can have color vision even in incredibly faint light. Some can even see ultraviolet light, maybe to spot bioluminescent signals.
Wow.
But yeah, for many deep-sea species, sight isn't the main game. The source mentions fish like fangtooth viperfish, bristlemouths, navigating that darkness. They rely much more heavily on their inner ear for sensing movement, and their super sharp sense of smell to find food and avoid being eaten. And then you have fish like the flashlight fish, which actually host glowing bacteria in organs under their eyes. They literally make their own light to hunt.
It's like a completely different reality down there. And similar to hearing, does their brain filter out the sight of the water itself? Do fish see water?
Yes, the source makes that point again for vision. Just like our brains filter out our nose or the air, a fish's brain filters out the constant visual input of the water. They don't consciously see the water, they see through it. This filtering lets their brain focus processing power on what matters. A predator moving, prey flickering, the shape of a hiding spot. It's that crucial neural trick of tuning out the constant background.
It's such a powerful reminder that their sensory world is just tuned so differently, calibrated for underwater life. Okay, hearing, seeing. What about tasting? Can fish taste the water?
The source says yes, they can taste the water if it has a taste, meaning if there are dissolved chemicals or substances in it. But here's the really wild part that sets them apart from us.
What's that?
Where their taste buds are. We have them mainly on our tongue, right?
Yeah.
Fish, according to the source, have taste buds on their tongue, sure, but also scattered all over the outside of their body.
All over their body? You mean like on their skin, their fins?
Exactly.
Yeah.
Skin, fins, tail. Even on their barbels, those whisker things some fish have. The source specifically mentions bottom dwellers like catfish. Their barbels are covered in taste buds, acting like sensitive fingers, tasting the mud and sand for hidden food.
So they're basically swimming tongues, constantly sampling the water's chemistry just by being in it.
That's a fantastic way to put it. The source says they can distinguish basic tastes, salty, sour, sweet, bitter, and they react instinctively if the water tastes wrong or interesting, maybe signaling food or pollution. Again, the constant taste of pure water probably gets filtered out, but any significant change gets noticed immediately. This all-over tasting is huge for finding food, especially in murky water.
Incredible.
Yeah.
Okay, and smelling, is that important for them?
The source emphasizes smell is arguably their most important sense for many species.
Most important, more than sight or the lateral line?
For many, yes. They have nostrils, usually two, on the front of their face. Water flows in, passes over sensory cells, and they detect dissolved odors incredibly well.
Why is smell so critical?
The source explains it's vital for tons of survival behaviors. It's a primary way they detect predators, maybe smelling chemical cues released by a stressed fish nearby. It's an early warning system, lets them flee before they're even seen, and it's absolutely essential for hunting. Often guides them towards food from far away, long before they can see or feel it. In that huge, complex underwater world, smell provides crucial information about who's around and what's happening.
So their senses, hearing vibrations and specific sounds, seeing light and maybe even electric fields, tasting with their entire body, and smell as a primary guide. It paints a picture of a sensory world that's just profoundly different, maybe richer in some ways than ours.
It definitely challenges our human-centric view of perception, doesn't it? They're experiencing their environment in ways we can barely even imagine.
Okay, one last point on physiology, and this one sounds simple, but the source says it's surprisingly complex. Salt content. Ocean fish live in salt water. So, are they really salty inside?
The source tackles this head-on. Yes, they are salty to some degree living in the ocean. And the source even notes oceans are getting saltier. But here's the biological twist. The source states that despite living in wildly different environments, the ocean at roughly 35 parts per thousand salt, freshwater, less than 0.5 ppt, both saltwater and freshwater fish maintain basically the same internal salt concentration, about 10 ppt.
Wait, they have the same internal salt level, whether they live in the ocean or a lake. How is that even possible?
That's where this critical biological process called osmoregulation comes in. The source details it. It's this complex system for keeping the balance of water and salts right inside their bodies, even when the outside world is constantly trying to mess it up.
How does it work? It must be different for fresh versus saltwater fish.
Totally different challenges. For freshwater fish, their insides are saltier than the water around them. So water is constantly trying to flow into their bodies and salts are trying to leak out. To fight this, freshwater fish barely drink, pee out tons of very dilute urine to get rid of excess water, and have special cells in their gills that actively pump essential salts into their bodies from the water.
Okay, pumping salt in. What about saltwater fish?
Opposite problem. The ocean is much saltier than their insides. So water is constantly trying to flow out of their bodies and salt is trying to flow in. They risk dehydrating even though they're surrounded by water. Saltwater fish counteract this by drinking seawater constantly. They absorb the water and then use specialized cells in their gills to actively pump the excess salt out of their bodies back into the ocean. And they produce very little, very concentrated urine to save water.
Wow, that sounds like a huge amount of biological work, just constantly pumping water and salt around to stay balanced. It sounds exhausting.
It is. It's a massive energy cost, which is why, as the source points out, most fish species are stuck. They can only live in either freshwater or saltwater. Their osmoregulation machinery is specialized for just one environment.
Most fish, but not all. Are there exceptions? Fish that can handle both. That sounds almost impossible given how different those mechanisms are.
It's one of the most fascinating adaptations the source mentions. It actually lists specific fish species that have evolved the incredible ability to switch between fresh and saltwater. They can adjust their internal plumbing, essentially.
Seriously, who are these biological superheroes?
The source lists several. The American eel born in saltwater grows up in freshwater, then goes back to the sea to breed. Atlantic stingray, barramundi, which is a type of sea bass, and get this, the bull shark, famously found way up freshwater rivers. Green sawfish, Gulf sturgeon, and another classic example, sockeye salmon, migrating between rivers in the ocean.
A bull shark managing freshwater. That osmoregulation flexibility is just incredible. Truly a marvel of evolution.
It really is. Shows the extraordinary biological adaptability that can happen under the right pressures.
Okay, let's move from the internal workings to some external behaviors, starting with the most fundamental need, eating. What do ocean fish actually eat?
Well, the source makes it really clear. There's no single answer. The diet is incredibly varied, depends entirely on the species, its size, where it lives, its spot in the food web.
So it's everything from microscopic stuff up to, well, other fish.
Exactly. The source gives a huge range of examples. Lots of smaller fish eat small crustaceans, things like krill, shrimp, tiny lobster, and crab larvae, barnacles, prawns. They also eat larger mollusks, worms, jellyfish, that kind of thing. But then you get specialists. Sharks, as apex predators, eat lots of stuff. Other fish like tuna, marine mammals like seals, turtles, mollusks, even other rays. Rays themselves often munch on bottom dwellers, clams, oysters, crabs, snails.
And what about fish eating other fish? Is that common?
Oh, very common. The source mentions fish like snappers. When they're young and small, they might eat plankton. As they get bigger, they switch to small fish and mollusks. Bass are often predatory too, eating smaller fish, but their diet can also include plankton or even vegetation. And then you have really aggressive examples. The source mentions lionfish, notoriously predatory, and have even been seen eating smaller members of their own species. Cannibalism.
Yikes. The diversity in diets is just as huge as the diversity of the fish themselves. The source also mentioned a specific behavior sometimes seen, especially in pet fish, picking up stones or gravel and spitting them out. Why on earth do they do that?
Yeah. The source explains this is directly linked to their natural foraging instinct, their drive to find food. Whether they're in the wild or a tank, fish are often checking things out for potential meals. In a tank, maybe if they expect food, or if the tank is a bit bare, they'll investigate objects with their mouths. Picking up gravel is part of that exploration. Is there anything tasty stuck to this?
So they're not just playing with rocks, they're actively sifting.
Precisely. The source gives the example of cichlids, which are famous for this. They'll deliberately scoop up mouthfuls of gravel or sand, swish it around in their mouths to dislodge any tiny organisms, algae, or bits of food, and then spit out the clean, inedible gravel. It's a feeding strategy.
That makes so much more sense. Active food processing. Speaking of eating habits, can fish actually get overweight? We see fat cats and dogs. What about fish?
The source confirms, yes, fish can become overweight, but it also notes it's pretty rare out in the wild ocean.
Why the difference? Ocean versus fish tank?
Well, in the context of pet fish, the source explains overfeeding is a really common issue. Unlike the wild, food in a tank is usually reliable, plentiful. If owners give too much, the fish eat it. And yeah, that leads to obesity, which the source warns can cause serious health problems, even be fatal for aquarium fish. It strongly advises following the feeding directions on the food package.
Makes sense. So why is it rare in the ocean?
Because food out there isn't guaranteed. It's often unpredictable. Fish are wired to eat when they can, but they don't usually get enough consistent excess food to become harmfully obese. Instead, the source says they tend to store fat deposits in their bodies.
And those fat deposits are useful in the wild.
Yeah, crucial survival tools. Those stored fats are energy reserves. They help the fish survive lean times, periods when food is scarce. They fuel them during fasting. The source even links the delicious taste of some fish, like salmon, partly to their higher fat content, which they build up during feeding times to power demanding things like migration and spawning. It really shows the different metabolic strategies. Wild fish adapted for scarcity, captive fish vulnerable to overabundance.
Really underscores the difference between a controlled environment and the wild. Okay, let's talk about raw fish, but from our perspective. The source had some info on eating ocean fish raw. Is that generally safe?
The source gives a balanced perspective here. It advises that, generally speaking, it's probably best not to eat most ocean fish raw because of potential risks. However, it definitely acknowledges exceptions exist, and certain types are commonly eaten raw, but only if specific conditions are met.
Okay. Which types does the source mention as usually being okay? Assuming, proper handling.
The source lists salmon, tilapia, and yellowfin tuna as examples. Fish generally considered safe to eat raw if they're healthy fish to start with, and crucially are prepared correctly to minimize risks.
And are there types the source specifically says never eat raw?
Yep, it explicitly lists haddock, largemouth bass, which is often freshwater, but it's mentioned here, and pollock. Those are on the never eat raw list, according to the source.
And the preparation part seems key.
Absolutely critical. The source really stresses this. Even for the safer fish, you must know and follow the right preparation methods. This often involves specific handling, super cold storage, sometimes freezing protocols specifically designed to kill potential parasites like worms.
Right. The source also mentioned potential health benefits and risks. What are the upsides it lists?
According to the source, eating certain raw fish might help you feel full, potentially aiding weight loss. It describes some as very nutritious. It lists possible benefits like reducing risks of depression and some cancers, providing antioxidants. Also, having minimal chemical exposure compared to maybe processed foods, enhancing brain function, being high in those good omega-3 fatty acids, and having no cholesterol.
Sounds pretty good. But what about the downsides, the risks the source mentioned?
Yeah, gotta have the full picture. The source also lists potential negatives from eating some raw fish. These include the risk of getting parasites, like tapeworms, nasty, exposure to harmful bacteria that cause food poisoning, and potentially accumulating environmental pollutants like heavy metals or PCBs that build up in fish tissues.
So the source paints a picture where eating raw ocean fish isn't a simple yes-no, it's complex. Choose the right species, understand the dangers, and be absolutely meticulous about preparation. Be informed.
Exactly. Make educated choices based on the specific fish and how it's handled. That's the advice.
Okay. One last topic in this behavior section, and it's a question that comes up surprisingly often, usually with a bit of a giggle. Do fish fart?
Yes, the source tackles this common query with some biological precision. If we define farting very specifically as expelling digestive gas produced during digestion from the rear end, then the source says generally most fish do not fart like that.
Generally, no. Are there any exceptions, fish that do produce digestive gas farts?
Interestingly, yes. The source lists herring and sand sharks as potential exceptions that might actually expel gas from their digestive tracts.
Herring and sand sharks. Okay, so most don't. But sometimes people see bubbles coming from a fish's rear and assume, it's usually happening there.
The source explains that what's often mistaken for a fish fart is actually related to their swim bladder.
Ah, the buoyancy thing.
Exactly. Many bony fish have this internal gas sac, the swim bladder, to control buoyancy. Add gas, they float up. Release gas, they sink down. Helps them hold steady without swimming constantly. When they need to release gas from that bladder, the air usually travels through a duct connected to their gut and gets expelled, but typically through their gills or their mouth, not the anus.
So it's just letting air out of their internal life jacket, not digestive gas.
Pretty much. It's for depth control. The source gives the sand tiger shark example. Again, they don't have a swim bladder, but achieve buoyancy by gulping air at the surface. They then release this air from their rear end to adjust their depth. So air is coming from the rear, but the source points out it's not digestive gas. It's swallowed air for buoyancy. Whether you call that a fart depends on your definition, right? Any air from the rear or specifically digestive gas. The source leans towards the digestive gas definition.
Got it. So generally no, unless you're a herring or a sand shark letting out buoyancy air. Clears up a common misconception with actual biology.
It does. Shows even silly-sounding questions can lead to some fascinating biological details.
Okay, we've looked at their bodies, their incredible senses, their behaviors like eating and, well, not farting usually. Let's move into a potentially trickier area the source touches on. Fish sentience, awareness. Do fish get bored, for instance?
The source suggests it's tough to say definitively for fish out in the huge dynamic ocean. But there is evidence suggesting that fish kept in aquariums can show signs that look like boredom.
Why the difference? Ocean versus tank again.
Seems so. The source attributes it to the richness and constant change in the wild. Ocean fish are always interacting with other life, navigating complex environments like reefs, dealing with changing currents, light, weather, constant stimulation. An aquarium, though, unless it's really well set up with lots of decoration, hiding places, maybe tank mates, can become pretty monotonous, especially for smarter or more active species.
So, lack of stimulation is the culprit. What signs of boredom does the source mention in aquarium fish?
It suggests that long-term lack of stimulation can lead to noticeable signs of distress, or what we might interpret as boredom. Things like just stagnation, sitting listlessly, not engaging with anything, and even, sadly, in extreme cases, self-harm, like repeatedly rubbing against objects.
Wow.
It leads the source to conclude that, yeah, like many other animals, fish seem to need environmental stimulation and enrichment to thrive.
That's a really powerful point for anyone keeping fish. They need more than just clean water and food. They need an engaging world. Okay, moving to an even deeper concept. The source touches on awareness of dying. Do fish know when they're dying?
The source approaches this carefully, thinking about cognitive awareness and self-identity. It states that for the vast majority of the animal kingdom, while they definitely experience pain and stress, they likely lack that complex sense of self, that identity, required to truly understand the concept of their own death. That they are slipping into another world, as the source phrases it. It lists humans and maybe dolphins as among the rare exceptions thought to potentially have that level of self-awareness.
So they feel the physical process, the pain, the struggle, but not the sort of existential dread of, this is the end for me.
That's the distinction the source seems to make. As vertebrates with nervous systems, fish absolutely feel physical pain. They feel stress during injury or illness leading to death. Their body reacts instinctively, that fight for survival. The fight or flight response is hardwired. But this physical, maybe basic emotional reaction is distinct, according to the source, from the complex cognitive grasp of one's own mortality.
It's a subtle but important difference in what that experience might be like for them. What about their response to other fish dying? Do fish get sad when another fish dies?
The source suggests that while fish brains are capable of various emotions, they probably don't experience sadness in the complex, layered way humans do, tied up with abstract ideas like loss and grief. However, the source is clear. Fish do notice and react when other fish around them disappear.
They notice when others are gone. The source mentioned earlier fish having enemies and friends suggests some social awareness.
Yeah, that phrase, enemies and friends, implies some level of social recognition or interaction within their groups. And the source explicitly says they notice when one of these friends or companions vanishes.
Is there an example from the source to illustrate that?
Yes. Specifically in the context of pet fish again, the source offers a really poignant observation. If one fish in a tank dies, the remaining fish don't just carry on obliviously. They might show changed behavior, sometimes swimming repeatedly to the specific spot where the missing fish used to hang out. And here's a striking detail. The source adds that in some cases, the very last fish left in a tank, after its companions die, might itself die sooner than expected.
Wow.
The source attributes this potential early death to what could be interpreted as, well, loneliness, or at least the stress of isolation.
The possibility of loneliness in fish, that's quite profound. Suggests a need for social connection we might not normally think about.
It really does. The source also offers a perhaps more instinct-based alternative interpretation for their reaction. Noticing a companion is gone and maybe being stressed by it could stem from a heightened sense of danger. If a buddy disappeared, maybe a predator got them and that predator can still be around. The absence signals risk.
Ah, okay, so maybe not human-level grief, but definitely a response to social change, whether driven by a sense of loss or a sense of increased threat. It shows awareness of the individuals around them beyond just being part of a school.
It definitely adds layers to how we think about their inner lives and social dynamics.
Wow, we have really covered a lot of ground today,
Yeah.
taking a truly comprehensive deep dive into the world of fish, peeled back layers on everything from our own mistaken ideas about them to their intricate biology, their frankly amazing sensory abilities, diverse behaviors, and even these hints of complex awareness like curiosity, recognition, maybe even loneliness.
Yeah, hopefully this journey through the source material has given you, the listener, a kind of shortcut, a way to get well informed about some incredibly surprising facts and insights about these underwater creatures we so often just overlook or misunderstand.
Absolutely.
Yeah.
The next time you encounter a fish, maybe just watching one swim past in a river, looking into a tank, seeing one at the market, or perhaps if you're lucky enough to see them snorkeling in their own world, you might just find yourself looking at it differently.
Appreciating the complex life that's happening just beneath the surface.
Yeah.
And considering everything we've unpacked from the sources today, the fact they might not fear us like we thought, but might just be curious. Their ability, maybe, to recognize faces, their capacity for physical pain and stress, that moving suggestion they could experience something like loneliness, and how they perceive the world through senses so alien to ours, feeling vibrations, detecting electric fields, tasting with their whole bodies. It really does leave you with a compelling question, doesn't it?
What question is that?
Just how much of the underwater world and the rich, complex lives being lived within it still remains completely beyond our current human understanding? What other unexpected depths of behavior, sensation, awareness are still out there, waiting to be discovered, just by looking more closely and thinking a bit differently about the life that surrounds us, even the life we think we already know?